The traditional method of making engines was to pour molten aluminum into a mold. But this leads to structural weaknesses in the metal.
You done the old cast aluminum block was not a good quality piece to use.
To solve that, machinists now mill each engine out of a single 700-pound billet of compressed aluminum alloy.
After it's poured molten into a shape is forged, which is an impact process which condenses it into a cube and also condenses the grain structure and the molecular structure, making it very dense, very solid, and very uniform.
But actually carving an entire engine block from a dense alloyed metal is no easy job. Which is why DART calls in a high-tech machine called a CNC.
CNC is computer numerical control, and that refers to the fact that a computer program is driving all of the cutting tools in the machining center.
The CNC attacks the billet with a series of sharpened carbide steel drill bits. The much harder steel blades easily shape the lighter and more pliable aluminum, all according to a tricked-out 3D design.
When we rough the blocks, we'll machine like the roughing tools will run 4,000 RPM, 240 inches a minute. We can make 1.5 yards of chips in 2.5 hours.
They remove a lot of metal in a short amount of time.
By the end, the 700-pound billet is whittled down to an engine block weighing just 140 pounds. But before the engine is ready for the heat of competition, it undergoes a final process. Each engine spends 12 hours in a 300-degree oven. The process is called heat treating, and it does something remarkable to this once solid cube of aluminum.
The heat treating process aligns the molecules, the grain structure of the metal, and it ultimately makes it a much stronger, much more uniform, and much more stable piece.
The entire process produces aluminum engines strong enough to pound out more than 2,100 horsepower, almost 3 times as much as a NASCAR racer.